Good morning and good afternoon. This is Matt C. and Jeremy Q, and this recording is for community contribution for EDAV 5702. In this demo, we will be using R to introduce geospatial analysis, specifically the SF and TMAP packages. So the first question we want to ask ourselves is, why do we use spatial analysis in the first place? In many cases, using traditional plots such as scatter plot, box plot, or histograms are not enough, as we may want to harness the inherent spatial context of data. Geospatial visualization helps us understand where patterns and phenomena occur, adding an important dimension that a histogram or a simple chart cannot convey. So in this demo, we will be showcasing two different packages, namely SF, which is used for spatial data manipulation, and TMAP, which is used for spatial mapping visualizations. So before we start with the visualization and delving into the two packages proper, we want to first understand what a spatial data is about. So spatial data files exist in a few different file formats, most commonly shape files and GeoJSON files. It exists in a few geometric types, including points, lines, and polygons. And we can apply distance, intersection, buffer, union, and containment, and other more complex operations to these different geometric data types. We first want to understand how do we apply a TMAP in the first place. So similar to a ggplot, we are adding layer by layer using the R script. So as we can see here, we are first applying a base layer of the census tract map onto the TMAP, and after that, we are adding the car ownership layer onto the TMAP afterwards. This will help us generate a pretty TMAP where we are able to visualize where the car ownership is higher and where the car ownership is lower. So evidently, central London experiences lower car ownership than outer London. On top of that, TMAP also have other functionalities important for spatial visualization. For example, adding a north arrow and adding a scale bar, as shown here. We can also adjust the TMAP layout, adding the title, font family, font size, and stuff like that, just similar to ggplot. Next, we would like to introduce two different techniques that are commonly used in spatial analysis. The first one is point layer analysis. Point layer geospatial is a very common type of layer, and in this case, we are visualizing the positions of the London stations on top of the car ownership, as observed here. We next want to visualize certain intercepts that may happen. So in this case, when we are dealing with point layers, we could perform interesting point layer techniques such as buffer, showing a certain buffer around an area. In this case, we set the buffer to 1 km, which is a reasonable walking distance for a person to walk back home after taking a train. In this map, we notice areas near train stations do not exhibit a clear relationship with car ownership in the area. It is more related to how close it is to city center. Next, we would like to showcase another type of spatial analysis technique called spatial autocorrelation. We show some capabilities of geomapping using the example of spatial autocorrelation. Spatially, we assume that places near each other have spatial interactions and therefore show correlation and similarity in the target feature. How this is useful is that it helps us pinpoint areas where a hotspot or a cold spot may occur for a certain feature, and therefore this will help us introduce policies. In this demo, we use Getty's odds GI statistics on percentage of people using sustainable methods of transportation. This test identifies hotspots and cold spots, which are statistically significant clusters of features with high and low z-scores respectively. In this case, we are using the Queen contiguity because neighborhoods share a common boundary, and therefore spatial interactions will increase in that case. So using this function, we are able to generate a hotspot and a cold spot map of sustainable travels to work. And we can obviously identify certain areas, for example, the area on the left side of London and two areas on the right side of London where there is a clear hotspot for sustainable methods of travel to work. And from here, we will be able to understand whether what are the policies being applied in these certain districts that may have impacted people to be more willing to travel to work. So this short demo showcases TMAP as well as SF and the power of spatial visualization using these various packages. Of course, spatial analysis is much more complicated than this, and therefore we have dropped a few links for interested readers to continue reading below the video. Thank you so much for watching this